What's up, everybody? My name is Gamonal. I'm here with Gamonal Tutors, and today we're going to be adding and subtracting fractions. So welcome to another video of Gamonal Tutors, where confidence breeds competence. So if you'll recall, last time we were going over fractions and what their equivalents are, kind of what a fraction means. So a fraction is just a portion or a part. It's another word for portion or part. In this case, we used one whole sheet of paper, and we created 1/3 of that sheet of paper to be our fraction, our part that's ours. Everything else is just remaining, but this fraction is what is ours. And what we found out last time in rewriting and changing the name of fractions is that 1/3 is the same as, in this case, with this picture, if you look, it's going to be the same as 1, 2, 3, 4, 5, 6, 7, 8 out of 24. This is all 2, 4, 6, 8, 2, 4, 6, 8. So 8, 8, 8, 1/3 of it is going to be 8/24. We did this with 1/2 also, and we found out that the more that you folded it, the only thing that stayed the same was the portion that was ours. So 1 is half of 2, just like 1, 2, 3, 4, 5, 6, 7, 8. 8 is half of 9, 10, 11, 12, 13, 14, 15, 16. 8 is half of 16. So the idea here is that 1/2 equals 8/16. Let me write that a little bit bigger. Alright, so 1/2 equals 8/16, which is also equal to another half fraction that's popular. The easiest one is 2/4. Right? If you can imagine this sheet of paper split up into 4s, which is what we did in the beginning. We said this is 1, 2, 3, 4, and 2 of them are filled in. So 2 is half of 4, which is the same as 1/2. And then let's check out 1/3. 1/3 is going to be equal to, what was the one that we said? Let's count them out real quick and make sure we know. 2, 4, 6, 8. 8 out of 24. Alright, and another example of 1/3, if we times it by 2 halves, which is the same as timesing by 1 whole, we'll get times 2, 1 times 2 is 2, and 3 times 2 is 6. 2/6. Alright, so those are some different ways to write the same fraction. All of these really mean they reduce down to 1/3, but they are different ways of writing it. And the reason that you would want to change the fraction, the portion, is so that you can add and subtract fractions, right? If you recall last time when we went over this, we were trying to figure out how to combine these two fractions, alright? So what is 1/2 plus 1/3, right? We were able to see that it's not quite 1 whole because it only fills in up to about that portion, maybe this last circle, thereabouts. And the trick is, the math trick, is you use common denominators, what's called common denominators, alright? So, what you want, the denominator, so numerators go on top. You're going to want to write that down, and denominators go on bottom. Alright, and you'll recall as well, numerator is going to be portion, and denominator is going to be whole. So this line, we said, is the same as the division line. It always means like per, right? So 3 per 6, or 1 per 2. So 1 per 2 is 1 out of 2, which is 1/2. 1 out of 3, 1/3. So the numerator in this one is going to be 1, the denominator is going to be 3. I'll let you guys figure out the numerator and denominator of this one. Numerator here is going to be 2, denominator is going to be 6, therefore our portion is 2 out of 6. Alright? Now, for adding and subtracting fractions, let's erase this up. We're going to use our sheets of paper first, and then we're going to do the math behind it. We'll use the board after. Alright? So, the sheets of paper here, these ones are already broken into like a million pieces. So I'm going to flip them over and just use the back to kind of make it simple. So, this is our 1/3, right? And 1/2 is easy enough. We split it right down the middle. So go ahead, if you're doing this, you can color it in different colors. Hopefully you guys got to fly some paper airplanes if you were following around last time. Maybe do a little origami. 1/2 and 1/3. 1/3. Cool? So, now what we need in order to solve this is we need this 1/2 to be in terms that the 1/3 can be in as well. Alright? So what you look for is the lowest common multiple. So if you know your multiplication facts, this becomes a lot easier. And the multiplication facts, you'll recall, we've gone over with our card game. So if you don't know your 2 and 3 times tables right off the bat, definitely get more practice with the cards. But I'm going to write them down for you, just to help you out. So we start with 2. Next is going to be 4. Next is going to be 6. Next is going to be 8, 10, 12. Alright, and we're looking for the lowest common multiple, and we'll come back to that. But now let's try 3. 3. So 3 times 1 is 3. 3 times 2 is going to be 6. 3 times 3 is going to be 9. 3 squared. 3 times 4 is going to be 12. 3, 6, 9, 12. And let's do one more. 3 times 5. 5, 10, 15, right? Alright, so now what we're looking for is a common multiple. Alright, I'll use green. So our common multiples are multiples that are the same between both numbers. So in this case we have 6 and 6. And then, do we have any more? 12. 12 and 12. Alright? Now, which one's the lowest? The lowest common multiple is going to be 6, right? So what we want to do is split this one into 6. Alright? Now, right now it's already split in half. So the way you split it into 6 is you fold it into thirds. Kind of like that. Alright? So I'll fold it into thirds over here off to the side. And hopefully you guys can do this at home. You may want to use a separate sheet of paper so you don't get lost in the weeds here. And then I'll draw in a line. Alright, check it out. 6 even fractions, 6 even parts of our whole paper. So, how many of them are filled in? It looks like 1, 2, 3 out of 4, 5, 6. 3 out of 6 are filled in. So, our fraction for 1/2 that we want to use is going to be 3, 6. 1/2 equals 3, 6. And then our fraction for 1/3. We're going to use 6 again, so we know that that's going to be the common denominator. But let's see if we can flip that on our paper. So this is our 1/3. Now I got to split this in 6. So this goes from 3 to 6. How do I do that? I times it by 2. To times it by 2, I cut it in half. Hopefully this gives you an idea of how multiplication and division are actually kind of the same thing. They're like same parts, or 2 sides of the same coin. Alright, so split this in half, which doubles it. Crazy how that works. Alright, and now I have 6 equal pieces. So 1, 2, 3, 4, 5, 6. So how many are filled in? Looks like 2. 2 out of 6 are filled in. And now we can finally do the addition. So we'll take the 2 sheets of paper. We have 3 6. These 3 6 plus 2 6, right? So I'm not even write it. You'll see that you can't add the denominator because there's a 6 left over here. You don't want to add the denominator, you're just going to add numerators. Alright? So 1, 2, 3, 4, 5. 5 out of 6 pieces. That's our solution. Alright? Now, again, you can do this with other types of fractions. You could create a fraction where you cut it into 4 and then 1/4 and then fold it over and over again to find something that's even between 1/4 and 1/3 or something like that. And that's basically what you do. When you get better at math, you don't even use the sheets of paper, you just do it in your head. And you memorize your multiplication facts, which is why we do those card games, so that you are the fastest in the room at adding and subtracting fractions. Alright? And that's everything. Like when you get good at your operations, you get good at all of math. And then we're going to go over this 12 real quick too. Let's say we were to use 12. So we were doing 1/3 plus 1/2. And then I will change it to that with a 12 denominator. So the math way, the way you write it out, you start with 1/3 plus 1/2 equals what? Alright? First thing you got to do is find the lowest common multiple, lowest common denominator. So our most common denominator is going to be 6, as we discovered earlier. Now let's say you're not that great of a math student and you didn't notice the 6. Say you noticed the 12. 12 is our lowest common denominator. Alright, I'm going to go back. I'm going to be doing both of these at the same time. So, how do we turn a 3 into a 6? You times it by 2, right? Whatever you do to the bottom, you have to do to the top. It's like the common saying. So, we're timesing it by 2 halves, which is the same as timesing by 1 whole, which is the same as timesing by 1. Anything times 1 is just itself. So, what's 3 times 2? 6. What's 1 times 2? 2. Alright, so this and this are the same. Plus, what is 2 times, or how do we turn 2 into a 6? We multiply it by 3. So 2 times 3. And whatever you do to the bottom, you want to do to the top. So 2 times 3 is 6. 1 times 3 is 3. 2 6 plus 3 6 is equal to, and like I said, we don't add the denominators because the pieces don't change, right? The number of the times that we cut or folded our paper isn't what changes. What changes is we're adding those two. That's the operation. We're putting those two together. So 2 6 and 3 6 equals 5 6. Alright? So the answer is 5 6. And you go back and you write your answer. And that is correct. 100%. A+, right? But let's go back to our math student who's not that great. Didn't notice the 6 was the lowest common multiple and wanted to use 12 as the lowest common multiple. So if we do 12, we'll see here, how do you turn 3 into a 12? Let me erase these 2's and these 3's, because now we're not turning it into 6, we're turning it into 12. So what is 3 into 12? You times it by 4. Or quarters, right? So 4's, whatever you do to the bottom, you want to do the top. So we're timesing it by 4 fourths, 4 out of 4, which is 1 whole, so we're not changing the number. 3 times 4 is 12, done. 1 times 4 is 4. We don't want to change our addition symbol, we still want to add these fractions. And then how do I turn a 2 into a 12? Well, you turn a 2 into a 12 by timesing it by 6. So whatever you do to the bottom, you want to do the top. I'm timesing 1/2 by 6 6, which is the same as timesing 1/2 by 1 whole. 2 times 6 is 12. 1 times 6 is 6. All right, so now we have 6 twelfths plus 4 twelfths. And I can even do this on our little sheets of paper here. We want to fold this in half. Let's see, because we're multiplying it by 2. It's already split into 6, so we want to make twice as many squares as we have. So what I'm going to do is you want to fold it so that this is the only portion shown, if you can. Cool. So now that is the only portion showing, and you fold that in half. Now all these edges are already done for me because we went over this the other day, but when I fold it in half again, I turn it into 12. So times it by 2. Alright, so now I have 12 equal parts. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it's 4 out of 12, which is what that says. 4 out of 12. So far so good. Now 6 twelfths. How do I turn this guy into 12 pieces? Well, that's easy enough. I fold it up so that it's just 1 6 showing. And then fold. So now this is 1 6. I fold that in half. And then I can unfold it. And now I've doubled my 6 pieces into 12. There we go. Beautiful, right? We have, this is our half sheet, so half is equal to 1, 2, 3, 4, 5, 6. 6 out of 7, 8, 9, 10, 11, 12. 6 twelfths. Cool, right? 6 twelfths plus 4 twelfths. Now, what is 6 plus 4? It's going to be 10. And this is actually a great way to learn addition, is to find out all the numbers that make 10, and then kind of go backwards from there. And that's something I could go over. That's a little lighter. But 10 twelfths. Now, my question for you, is 10 twelfths the same as 5 6? The way that the math teacher asked this question is, can you reduce 10 twelfths? Now, reducing is the same as finding a common denominator. It's just in reverse. All right? So now, rather than looking for a lowest common multiple, we're looking for the greatest common factor, a number that fits into 10 and 12. And if you're a good student, you know that there's a really simple number that fits into any number that ends in 0, 2, 4, 6, or 8, any number that's even. The number that fits into any even number is always going to be 2. 2 always fit into any even number. So 2 goes into 10 how many times? So you divide the top by 2, divide the bottom by 2. And again, this is dividing by 2 halves, which is just like dividing by 1, which doesn't change the number. Just like we said earlier when we were dividing by, or timesing by 4 fourths. 4 fourths is just 1 whole, so it doesn't change the number, just changes the way it looks, right? So we're dividing 10 divided by 2 is going to be 5. Half of 10 is 5. And then 12 divided by 2, what's half of 12? 6. And so you get the same result. 10 twelfths is equal to 5 6 is equal to 1/3 plus 1/2. Alright? The giant overarching concept is this is how you're going to add fractions. Alright? It's cool, it's all fine and good to be able to figure out different ways to write fractions. That's probably the most important part. But adding them together is going to be like your bread and butter. If you can do this, you're going to be top of your class. Alright? So, let's go back. If we can add them, then we can definitely subtract them. And we can bring it back into integers. And then you'll be golden. So integers are any positive or negative whole numbers. But we're going to use positive and negative fractions. So I'm going to say 1/2 minus 1/3. Alright? Using our sheets of paper, if I take a half sheet, that's a half sheet, and I take away 1/3 of a sheet, So I start with this guy, and I take this much away. How much do I have left? What is that portion there, right? That's what I want to find out. So that's what we're going to be working on now, all right? 1/2 take away 1/3. Now, you're going to do the same thing. You're going to find the lowest common denominator. Lowest common denominator between 2 and 3 is going to be 6, if you will recall. So 6, and then we're going to use that 12 example again. All right? Now, I know this is repetitive for those of you who already know it, but this is a great review for you to understand where these numbers come from. All right? So how do we turn a 2 into a 6? We times it by 3. So 2 times 3, what's 1 times 3? Whatever you do to the bottom, you gotta do the top. 1 times 3 is 3. 3 into a 6, you times it by 2. 2 times 3 is 6. 2 times 1 is gonna be 2. And you subtract those guys out. So now rather than combining them together, they're taking away from each other. They don't get along, right? It's like the Utes and the BYU players, just like we said in lesson 1, where if these numbers are positive and negative, or subtracting from each other, they have to create a smaller number. They can't create a larger number. They can't combine to create 5, 6. They have to subtract to create, well, if I have 3 and I take away 2, I have 1 out of 6 left. So this is 1/6 that remains. Doesn't look like 1/6, but I guarantee you if I fill this out like this, that's going to be 1/6 of my entire sheet of paper. This section here is 1/6 out of the sheet. All right, using the 12ths now, if we're not that great at math and we found the wrong common denominator, no biggie, we can just reduce it later. So 3 goes into 12 4 times, so you times it by 4, times it by 4. 1 times 4 is 4. 3 times 4 is 12. Subtract. 2 goes into 12 6 times. So we times it, whatever you do to the bottom, you want to do the top. 1 times 6 is 6. 6 out of 12 is the same as 1/2. 4 out of 12 is the same as 1/3. 6 take away 4 is 2 out of 12. Now, the question being, is 1/6 equal to 2/12? If you'll recall, what we use is greatest common factor. What is a number that fits into 2 and 12? Just like last time, 2, 4, 6, 8, 10, any of those numbers are even numbers. 2 is going to fit into them. So we're going to divide both of them by 2. And 2 divided by 2 is 1. And 12 divided by 2 is 6. Cool? So the answer overall is going to be 1/6. Alright? That's what happens if you subtract them. So now we know what happens if you add them or subtract them. What I want you to think about is the integers. Alright? The integers on this is if we were to say, make it into a negative number. 1/3 take away 1/2. If I had, this is where it gets complicated. If I had 1/3 here, I take this much away. Now this is greater than this, so it's going to take away more than it has, and that's why we become onto the negative side of the number line. We're no longer on the positive. If I take 1/2 as positive and I take away 1/3, there's some left over there. There's a little left over, so that's how we know it's positive. But if I start with this and take this much away, it's going to be negative, right? Because this doesn't have enough to fight this. So the result is going to be a negative number. To show that real quick, we're going to switch these. 1/3 take away 1/2. And this is a good example of why number order matters in subtraction and division. The second number is taking away or dividing the first number. So therefore, you can't use the cumulative property. Like 3 plus 5 equals 8 and 5 plus 3 equals 8. But 3 take away 5 is -2 and 5 take away 3 is +2. That kind of idea, alright? For my speed thinkers. So, like I said, we're going to do 1/3 take away 1/2. We're going to use that formula that we went over in lesson 1 of subtracting integers, and we turn this into an addition problem. So it becomes 1/3 plus -1/2. Alright? Alright? So 1/3 plus -1/2, we see these don't get along, and that's when you have to know which one's bigger. What's bigger? 1 out of 3? If I cut a pizza into 3 pieces and eat one of those, or if I cut a pizza in half and eat one of those, which one's bigger? The half's gonna be bigger. So I know my result is going to be a negative number because we're taking away into the negative territory. All right? So 1/3 take away 1/2. Now we're back to the easy way. So we find the common denominator, which we've kind of beaten to death, is 6. We find our numerators, so plus negative. The numerator is going to be 3 to 6 is times 2, so we times it by 2 halves, which is the same as times it by 1 whole. So we get 2 out of 6, which is 1/3, plus a negative 3 out of 6. We times these two by 3. Times it by 3/3, which is the same as times it by 1 whole. And you get 2/6 plus a negative 3/6. So if I have 2 and I take away 3, it gives me 1, but it gives me a negative 1. Negative 1/6. Alright? I hope you guys followed that, got something out of it. Should make some pretty good sense as far as that goes. What you would do from here, if you were tutoring it or if I were tutoring it, you go through and use different numbers, right? We've really gotten together with 1/3 and 1/2. Like, we did it with paper, we did it on the board, we did it frontwards, backwards, 3 different ways. And now that they really are familiar with 1/2 and 1/3, you go and switch gears. You switch into 1/4 and 1/3, 1/4 and 1/8, whatever numbers you want to use. The numbers are usually going to make sense. Try to start simple always. And one last thing before you guys go, I want to show you guys that I can solve the Rubik's Cube. So let me go get my cube real quick. Check it out, Rubik's Cube, totally scrambled, right? Are you guys ready? I'm gonna start my stopwatch. 1, 2, 3. All right. Oh, so close. Boom, look at that, solved, time. Ooh, 12.5 seconds. Not too bad. All right, guys, if you saw my Rubik's Cube trick and you know what it was, go ahead and put it in the comments. All right, I hope everybody has a great day. Have a happy April Fool's Day and stay safe out there. This has been Gamonal Tutors, where confidence breeds competence. Peace out, guys.